Hello, Dr. Lin.
Yes.
Welcome to Dr. Lin. He's from National Cheng Kung University. And today's title is Introduction to Remote Sensing. Okay, Dr. Lin, please.
Okay, thank you. Hello, everyone. Welcome to attend my course. And I'm Dr. Boy Lin. I'm going to introduce the remote sensing. So what is remote sensing? Actually, remote sensing is a technique to acquire information without physically contact with the object. For example, LiDAR is kind of a remote sensing. And also, the most commonly known is the optical satellite imagery with multispectral bands. And for LiDAR, I think another Professor Wang will introduce. So I will focus on the multispectral optical satellite imagery. So what remote sensing changes our life? For example, if we want to describe the range of Taiwan, we maybe use the latitude range from 21 degree to 25 degree and longitude range from 120 to 122. And the easternmost point is at somewhere, westernmost point is on somewhere, and kind of that. So I think we need a lot of words to describe the range of Taiwan. However, if we use an image and then use the point and the coordinate of each point, we can easily to use a picture to read the range of Taiwan. Another case, this is a route and we can check these two images, and you can see that these two areas have already changed during 2015 to 2017. And then it needs a lot of words to describe this change, including the position, also the area. So a picture is a word of 1,000 words. A series of pictures are worth even more. So you might ask, if remote sensing is so good, do we still need a traditional ground surveying? The answer, of course, yes, because all the adjustments to the remote sensing are coming from the traditional surveying. The traditional survey is still indispensable. Also, the viewing angles from the satellites are not always suitable for all the cases. For example, the left is the remote sensing image, and the right one is a map. If we cannot directly measure the remote sensing image because it's still, still need ground control point to match them together. Only the scale and the transform already fixed, and then we can do the measurement. So here I'm going to talk about the different type of remote sensing devices. They are from high altitude to low altitude, and there are satellites, and the middle altitude is aircraft and helicopters, and the lowest altitude is UAVs and drones. For satellites, it has the highest altitude. It's higher than 400 kilometers because it takes picture from so high altitude. So we can get a large land coverage, and you can see we take picture from so far distance. So the pixel, the image will have a coarse spatial resolution, which means the pixel is very coarse. We cannot see the object very clearly. And also, the coverage are limited to the fixed orbit. And also we are taking picture above the atmosphere, so there will be a cloud obstructions. The next one is the median altitude, aircraft and helicopters. And the height will range from 1 to 30 kilometers. So here, the land coverage will become median and also the spatial resolution. Also, we don't need to obey the fixed orbit because aircraft and helicopter is a pilot-flown flight path. We can fly wherever we want. However, because we need to fly it and we need to consider the weather. If the weather is bad, we cannot take off. Also, we can carry LiDAR on the aircraft and the helicopters. The final one is the lowest altitude, UAV and drones. And because the height is the lowest, so you get the smallest land coverage. But also because it takes pictures so close, so it has the highest resolution and call it very high resolution images, VHR. And also we can use the software to design or program the flight path. But also we need to consider the weather conditions, and it can also carry LiDAR. So as I mentioned, the spatial resolutions. Actually, there are three important image resolutions. There are spatial resolutions, spectral resolution, and time resolution. The spatial resolution represents the details in pixels of an image. For example, the left one is the low spatial resolution. As you can see, we cannot see the details on the ground. But if the high resolution, and we can see the buildings and also the field in the image. The second one is the spectral resolution, which means the amount of the spectral detail. For example, usually our UAV only have RGB 3 bands. But for satellite, we usually have more than 4 bands: blue, green, red, and near infrared. Or some kind of satellite also have the shortwave infrared and also thermal band. So it has a lot of bands and has a lot of spectral range information. So satellite will be a high spectral resolution image, and UAV will be a low spectral resolution image. And the final one is the time resolution. And is this the time for a satellite to complete a full orbit? And this is also, this is only for those with the fixed orbit, for example, the satellite. For Landsat A, the revisit time is per 16 days. And for Spot 6 and 7, they work together to get a revisit per day. And for UAV and drones and aircraft, they can flexibly design so they don't have the time resolution. Okay, here are the type of the remote sensing satellites. We have active sensors and the passive sensors. For active sensors, which means that the satellite will emit itself, it emits signal itself. So it don't need to consider the sun and the weather condition. And because the wavelength is used, the signal can pass through most of the clouds and the smoke. For example, Sentinel-1 is an active sensor that uses SAR. This is the animation. First, the satellite will send out the pulse and then receive the backscatter. So you don't need to consider the sun and weather condition. And this is the example image of Sentinel-1. Here, the color represents the strength of the backscatter from low to high. And because the signals can penetrate cloud and the smoke with its long wavelength, so here you can see the image is without clouds and smoke. And the second type is the passive sensors, which will sense the reflected light emitted from the sun, which means that sun will emit the sunlight, and then the sensor sense the reflected sunlight. So this system is similar to our human eyes. So the image are also very similar to those acquired by our eyes. And Landsat 8 and Sentinel-2 are the passive sensor acquiring images from the reflected sunlight. This is the example image from Landsat 8 OLI images. So we can see that color is similar to those captured by our human eyes. However, because the wavelength is shorter, so we will got obstructions by cloud and smoke. And also, the passive sensor will record multispectral band information. So here I'm going to introduce the spectrum. From the wavelength from shorter to longer, we have gamma rays, X-rays, UV ray, and visible band, and then infrared, microwave, and radio waves. And for optical satellites, they focus on this range of the wavelengths. And the spectral will affect the color the image shows. For example, the blue band in Landsat 7 range from 450 to 530, and you can see that the range from the blue band, green band, and red band range is different from Landsat 7 and Landsat 8. So the color display is also different. So here, you need to care about using this kind of data. You need to do the normalization. And so what is the benefit of using multispectral information? Here, actually, each item has its special curve around the multiband. We also call it spectral signature. Something like that, the vegetation have its own signature, soil have its own signature, and water have its own signature. And the pattern will be like water just like going up and going down around the visible band. And the vegetation will be high in the green band, and then lower, and then got extremely high in the near infrared. So here, we can also use this information to generate a false color images, which use the near infrared as red band, and red to become green, and then the green showed in blue band. In this false image, the vegetation reflects most of the light in the near infrared. So here, we can check that the red area will represent the healthy vegetation. Besides, many researchers develop a lot of special index. For example, we have normalized difference vegetation index, and this is its corresponding formula, which means it will enhance the vegetation in the image. Also, we have normalized difference water index, which means we will enhance the water. And also we have the NDSI. It can enhance the snow, and this is corresponding formula. And this is the example of NDVI. You can see that even if this area look like it have a grass, but here in NDVI, it didn't show a high value. So the green color in the true color image is not very suitable for finding a healthy vegetation area. And this is the index of NDWI, and you can see that the water area is not very clear by the true color image. But if we use NDWI, the water area will be enhanced by the red color. Also, the NDSI is finding the snow area. If we use the true color image, it's hard to identify that this area is cloud or not. But you can see that here, in here, we have cloud, also color in white. But here in NDSI, the cloud will be not enhanced, but the snow will be enhanced. Also, the lake, iced lake. And then it's the remote sensing applications. So if we need to, what remote sensing help us to do the analysis? For example, we can do the area analysis to do the natural resource management. For example, Bajada in 2018 just developed a method to use a remote sensing image to find a fishing zone area. And also, we can use the remote sensing image to find the natural forest biomass estimation. In traditional way, it needs a lot of human resource to finish the investigation. However, we can use the remote sensing image now. Use the image, we can reduce a lot of field work, and then use the image to estimate a large field of the information. Also, we can use that to do the change analysis. For example, the climate change and the environmental disasters. For example, we can use the remote sensing image to monitor the historical fires in Yellowstone. Here is the prone-fired area. We can estimate the area and the affected area by the fire. Also, we can use a time series of the remote sensing image to monitor the shrinking arrow sea. You can see that the sea around 2000 to 2014. The ROC is shrinking, become smaller and smaller. And also we can use the remote sensing image, multi-temporal remote sensing image to monitor the glacier retreat. So how do we perform these analyses? So here we need to know the images record the reflectance of light, which means the sun will emit the radiance and then captured by our eyes. If we capture all the light from our sun, and then the color we see will become bright color. It will become white. And if the reflected color is not 100% and become this kind of proportion, and then they will become its corresponding color. So here, the reflectance are linear transformed to a digital number, and the proportion of each band changes the colors. So here, the reflectance is from 0 to 1, and the corresponding digital number will become 0 to 255. So here, the green, red, and blue band, if their reflectance are all 1, which means the digital number are all 255, and we will see the color it become white. And if we have the digital number like this one, and then we will see the image color will become the yellow color. So the image, the digital number ranges from 0 to 255 is because each pixel is stored by 8 bits of the reflectance, 8 bit of the pixel. So here, which means that we have 256 digits. So the number will range from 0 to 255. And then blue band will record all the digital numbers, and then green band, and then red band. And for multispectral image, they will also record the near infrared, short infrared, and so on. However, some satellites not only used 8-bit to store the reflectance, they use 12-bit to store the reflectance information. So the digital number will range from, we will have 4096 digits. So here the range will become from range 0 to 4095. So what is the benefit of using so much bit to store a reflectance? Because we have a lot of digital numbers, so it allowed us to record more details in the strength of the reflectance. For example, this is the spectral signature of bushes. If we use 8-bit to record the blue band, green band, red band, and near infrared, as the near infrared is so high, so here we can not tell the difference between the blue band and the red bands. The difference is too small. However, if we use 12-bit to store the information, we can tell a lot of, the reflectance can be more, we can tell them apart using more pixels. So Actually, we can do the analysis with a lot of programming tools, but this course, I'm going to introduce the Google Earth Engine. And this is a free platform, and we don't need to locally read the image from our hard drive. Okay. So far, do you have any questions? If you don't have any questions, and Rabia, do you need time to break, take a rest?
Yes. I think it's fine.
Okay. Then the following will give you a tutorial of using GEE from Gabriel Yedaya. Okay. 26. Here is the color bar of the NDWI. The value 1 represents the higher probability of water, and the blue one represents the lowest probability of water. So here you can see the water will color around the red and the orange color. So here you can see below the clouds, and also here the river, and also here have the reservoir. Also a little bit water over here. So here is the color bar. The value higher represents the higher possibility of that kind of index, that kind of object. For NDWI will represent water, and for NDVI, the red or the orange color represent the vegetation, healthy green vegetation. And for NDSI, the index is for snow. So here, the red or near orange color will represent the higher possibility of snow area. Okay, thanks, Adila's question. Because your question is about why UAV image contain only RGB bands. I will mention here. Here I mentioned that UAV have a lower spectral resolution because it only have blue, green, and red band. And because UAV, the businessman want to sell it, and you want to sell it, the price cannot be too high. However, the near infrared camera is very, very expensive. So it's hard to see a UAV is carry on a near infrared camera. But we still can find some UAV have that kind of camera, but it's very, the amount is very small. But we can find it. But normally the UAV only contain blue, green, and red 3 bands. Okay. The next session will become my PhD student Gabriel to give you a tutorial of how to use Google Earth Engine API.
Okay. Okay, good afternoon, everyone. My name is Gabriel Lidaya, and for this sessions, I will help Mr. Oi to deliver some short demos and some introductions about Google Earth Engine's platform. Yeah. Google Earth and Google Earth Engine is a different platform that hosted by Google. Google Earth Engine is a cloud-based computing platform that hosted by Google. This platform can access multi-petabyte catalog satellite imageries and geospatial dataset, including Landsat imagery, MODIS imagery, Sentinel, sea surface temperature, precipitations or rain data, elevation data or DEM, and climate data. So how to use Google Earth Engines? The first thing you have to do is make a Google Earth Engine account. So create verify an email account that associated with Google. Use gmail.com is highly recommended for this session, or institution email also highly recommended, as long as those email associate with Google. So let's do the sign up first through Google Earth Engine. In here, yeah, for the sign up here, we can see that sign up for Google Earth Engines. In this session, I use an institutional email. I use my campus email. So my name is Kapil Dedaya, and my affiliation is National Chiang Kung University, and the institution type, you can fill that for the government, academia, non-profit, commercial, or non-affiliation, or others. So for this session, I use the academia, and the country region is Taiwan. Yeah. For these sessions, what would you like to accomplish with Google Earth Engine? You have to describe in few sentences at least 50 characters, because if you don't have 50 characters, for example, like this one, it will not work. So make a long sentence. Okay, for my remote sensing. Yeah. Okay. Maybe I will copy the link to the chat room. Where is the? Oh. Yeah, I will share the link to all of you guys. Okay. Here for the sign up for the Earth Engine account. So make sure you give your full name, your affiliation or institutions, the institution type, country, region, and make the long sentence like this one. I will use GEE as a cloud platform for my remote sensing research, and check everything here and do the verifications. Motorcycles. I think there is no motorcycles here. Buses. Check everything that look like bus. Verify and submit. Yeah, if you cut these notifications, you have to do the verification through your email. And here, welcome to Google Earth Engines. And try to Google Earth Engine editor here. Yeah, this account already signed up for Google Earth Engine, and the Google Earth Engine already for use. Yeah, I will tell you about the Google Earth Engine editor. Here for the interface, we have a live panel, editor panel, red panel, UI root, search box, and cloud project. And I will explain for live panel, editor panel, red panel, and search box. Also the mapping panel here. UI root is mapping panel. Okay. Yeah, this is the left panel. We have a script, document, and assets here. For the script, we have the function for script tab here is to save your script, to organize your script. So this is the editor panel to write your code, and we have a several button here: get link button, save button, run the code button, and clear the prompts, and get the link. But the difference is, if get link here, you got the this one. Search bar, left panel, editor panel, right panel. Wait. Yeah. So this is the left panel here. So the left panel here organize the programming script. GE document to show you about the Google Earth Engine's functions. Oh, I missed that. And Google Asset. This is the cloud space that provided by Google Earth Engines. 250 gigabyte for each account that you make for Google Earth Engines. And the editor panel here. I will show you. We have a get link buttons, save buttons, run buttons, clear the prompt button, reset button, and the add. Yeah, both of these use for get the link for your code. And the difference is, if you use get link here, anyone who have link, they can edit on their own account. So you share full of your codes. But if you get link through this button, anyone who have link only get the demo version. So no one can edit the codes from your code. So let's back to Google Earth Engine. So this one is right panel. We have inspector, console, and task. Inspector here to check the pixel value of your mapping image. The console is to display the output from print, call starts, and errors. And this one, the mapping panel or UI root here. Also the search box to find your data here. Okay, everything is done. The cloud project. Oh yeah, this data is provided. We can find the Landsat, for example, Landsat 9. Landsat 9 already provided by Google Earth Engine. And then you can find everything through this search box here. Yeah, browse data catalog, and you can see the data provided by Google Earth Engine, so surface temperature, climate, atmospheric, and the weather. Also a lot of images from Google Earth Engines. Because Google Earth Engine is a cloud-based, the downloading data is not necessary here. So no one, everything, yeah, red panels. Yeah, okay. Let's do the short demo using GEE. Wait, I will make a full screen. Yeah, because the GEE using a JavaScript, every command line ends with a semicolon here. So let's start with use the keyword var to create a variable. So for example, var migrate equal to 0 and end with semicolon here. If there is no semicolon, you got the notification missing semicolon here. And then using parentheses to pass the functions, the parameter to the functions, print hello world. Maybe I can copy to all of you. Oh, and print hello world and end with semicolon. Yeah, you can try to your site, print hello. If the code doesn't work properly, please retype the quotation mark here. Yeah, please retype the quotation mark if the code doesn't work properly. Yeah, the console for the print commands using console platform. And for the string object, always follow by quotation mark. So, for example, for comments, followed by quotation mark here, single or double quotation mark. GEE is awesome. So like this, and end with semicolon, always end with semicolon, and print comments, end with semicolon, and to the right. Yeah, GE is awesome. And use the square bracket here. Square bracket to make a list, So for example, I want to make a list of food here using quotation mark because I will use a string object burger, ice cream, and butter, for example, and with quotation mark. So if you use print my list, yeah, the console platform and the console tab will show you a list of your food here. So if I want to get the specific food, for example, I want to get the ice cream. So use the square bracket again, fill the number here, print my list number 1. So you will get the ice cream here. If you fill another number, example 4, is undefined because the item here, there is no 5 items, only 3 items. So let's continue with the curly brackets. The curly bracket is to use to make a dictionary. So the curly bracket is used to make a dictionary. So it means we have a list, there will be a key and value. So for example, for my dictionaries, I will fill the food again, food, and fill the value for food using burger again. I love burger. And again, the color of the burger may be color. The color is brown. And then the number of your order, number 40, and end it with square bracket, curly brackets, and with semicolon. print my stick. So using print commands to show the dictionaries on your console tab here. So the GE will show you the a list, but the different from the previous list, because we have a key for each list using food, color, and number here. So the different from previous, I will show you. Yeah. So the previous using 0, 1, and 2. This one using color, food, and number. It means this is the list and this is the dictionaries. And I want to get color. So using square bracket, because I want to get the value of our list from our list, a new list color. You got brown here. Another, yeah, color is better written in dot notations. So again, print my dictionaries dot color, because already become a key. So no need to make a square bracket here, because this one is the color is already key, become a key in your list. And this one also work. They will cut the color and there is no notifications error here. Just this one is better written in dot notations. So if you type food here, you will get burger like that. So, and then this is the programming basic in Java command. If you, oh yeah, sometimes we want to make a comment using a double slash. This is comment. This is using double slash to make a comment. So if there's a multiple line comments here, using slash and star, all of them become green because this one already become a comment, but we need to close it with star and slash. Yeah, this one is multiple line comments. So this one is for one line comments using double slash. Using double slash to make a comments. Oh no, S. Using slash and with star slash star and slash for multiple line comment. So this is the programming basic in Java for better, not better. This is the basic skill for programming in JavaScript language for GEE.
They have a question about density with Python or C++.
Is it compatible with Python or C++? I can say that yes. Several researchers already use the GEE platform and combine it with Python, but I don't think so with C++. I already read some researchers. They use the GEE combined with Python platform. They just call the GE platform and Yeah, there is Chi platform. They use the Chi platform to call all the data and use Python to process the data. And for the C++, I'm not sure about that. Maybe I will recheck it first before I answer it. Thank you, Kyle Rima, for your questions. Okay, for next part, I want to show you how to display, and clipping an image. How to display? Okay, I will show you. I will copy the codes, each line, to all of you guys. The first one, because we want to display and clipping an image, we have to load an images from Google Earth Engine data catalog. So from this case, I will load the Landsat 8 images, TOR reference here. Okay, I will, wait, I forget. If you want to try. Okay. Yeah, if the code have a error message, please retype the quotation mark until the line set become red color, because it is the image ID. This is the string object here. So if you run the code, there is no error message here. So after that, we have to add layer an image. Show you where is the images beneath. Part map add layer, it will show you where is the images you already load, and run. Yeah, to cut the image here. So this is the images of Miami. Yeah, is it Miami? Oh yeah, this is Miami. So use map command, set center. Oh, I don't know where is the locations here. So you use the inspector here to know where is the images beneath. You will get the latitude and longitude. Yeah, you just copy this one to map center and adjust your zoom level. Maybe I want to make a 10. And also remember, end it with semicolon here. Okay, I will copy this code for all of you guys. Yeah. And so let's far away from the images. Maybe I will try to Indonesia, hello Indonesia, and run the code. Yeah, we go back to our images with, this is the center object, center images, center view of our images. So from after we display an image, we want to visualize the images in RGB part, RGB color. Make so set the parameter for fish equal to minimum value of your images. Maybe I will fill it with 0 and maximal with 0.3 and select the bands because RGB bands RGB bands with band 4. Oh no, band 4, band 3, and band 2. Oh, by the instead using double dot. Yeah, there is no. Oh, I just missing semicolon here. Okay, I will copy this parameter to all of you. Oh, will we have access of this presentation too? Oh, yes, of course. I will upload these presentations after this session. So everyone can access and try the code because I already provided on this slide. I already provide each slide with the code and just disclaim with if the retype the quotation mark if the code doesn't work properly, and I will provide to all of you guys. So add a new layer with RGB color here. So put the visual parameter vis, and I will give the name lens at RGB. Let's run. Yeah, we already have the RGB color. This is the how to display an RGB images using the visual parameter here. Yeah, everything is great. Only forget the semicolon. Yeah. And then how to clip an image. Yeah, how to clip an image is very easy. The first thing you have to make a polygon, for example. I will. No. Yeah, make a polygon first. Maybe for this one, for example. Yeah, and then clip the image for my. Yeah, anything you want to give the name for my clip. My image dot clip using the clip functions to clip the image with the area of your polygon here. Because our polygon already named with geometry, so the clip with the geometry polygon, and then add a layer again to show the clip image. My clip is, and keep the name Landsat clip. Oh, I forgot the semicolon. Yeah, and run again. Yeah, you will get the 3 layers here. Layer 1, the black and white color image, RGB image, and Landsat clip. Oh, Yeah, you will see the clip images here. So this is the first tutorial how to display and how to clip an image and save the code. Yeah, the first you cannot change. Yeah, it's okay. Just okay. This is your username. Keep the new repository. I will keep the name TSU. How? Oh, 3 March 21st. Create. Okay, keep the name of this file. Display and clip an image. Yeah, this is the repository, and you already display and clip an image. So this is the first tutorial of display and clip an image. And then next, continue. Oh, just clear script. Okay, just clear the script. So the second tutorial, I want to show you how to composite and mosaic image, because some of us using more than one images, using multi-temporal. So continue with composite and mosaic image. Load Sentinel images collections, because the first one we already using Landsat. I want to show you how to use the Sentinel images. Okay, first I will show. Then load the Sentinel images. Yeah, if the code there is no warning notifications, it means it worked properly. And then make a polygon. You can use this polygon or create polygon wherever you want. I want to use this polygon. So yeah. Yeah, everything is fine. And again, filter the data through the date here, through the bounds, the image border, using geometry here, using this polygon, and filter metadata. We want to get the cloud cover less than 30%. So this is how to filter the image. And this one, oh yeah, this one can copy to your codes. Yeah. Oh yeah, if there is a warning notification, retype the quotation mark. I will reclaim that. Remind that. Yeah. Okay, everything is fine. Yeah. Try to print Havana. Topic. Yeah, we have 56 images. You can try to show your images. Print Havana. You will get the list of your images. There's a 56 images here. And then I want to count the images because I already count the image. Okay, using part count. Okay, I will, because I want to show the number of images. Part count Havana the size. You will get the size of your data sets. Okay. Oh yeah, this is.
I think the second polygon is the message is not
Oh, oh, it's not complete. Oh, okay. I will try again. Hmm. Yeah, this is the polygon. You can copy, I think. Yeah, 1, 2, 3, and 4 points to make a polygon, square polygon. Change it with print count. Yeah, you will get the 56 number of images. So how to get the IT images, the list IT of images? How to? So using print because we want to show the listed or IT images. Listed images. Havana dot to list. No. No, Havana. We can use count instead. Run. Yeah, this is the listed images. You will get the 56 directly. Not directly, the list of images. There are 56 images here. Already show. And then where is the Havana? Okay. There will be the big questions here. Okay, we can use a map center object because we use the polygon as the center. Geometry. Yeah, is it geometry? Yeah, is it geometry? And adjust to 10 maybe. And let's fly to Havana. Yeah, we are ready arrived. This is the Havana. And where is the polygon? You cannot show. Just convert it. Oh yeah, I forgot to copy this code. You can try. Yeah, this is the Havana, and I already convert my polygon as import. So you can see the polygon. I will uncheck. So we want to show all images one by one. Show the images from 56 images, I think. If it's too much. First, we can use a visual parameter again. Visual parameter using curly bracket. Fill the minimum value with 0, maximal value with maybe 0.3 again. It's okay. And then select the RGB band P4, P3, and again P2. Red, green, and blue bands. And close it with curly bracket and with semicolon. Okay, I think it's fine. No warning errors here. So we already zoom the images, already get where is the locations. We already arrived in Havana, and use the functions. Yeah, the functions. Where is the function? Yeah, this one. Display its image in collections. We use this function function add images. Okay, I will copy to all of you. I forget. Yeah, function add images, image through the image ID and add layer for each image. You see. Oh, I will expand. I think it's better. Yeah. Yeah. This function is used for show its image. For it will show the 56 images respectively. Function add images. We add an image through the image ID using the image ID here, and add layer with the parameter this parameter, and evaluate. It will run again until the images show all of them, and no semicolon here, end it with semicolon, end it with semicolon, and run. I think I forgot to copy this one for you guys. Make sure the visual parameter is above of this function, because they will read the visual parameter first and run the codes after that. So see, this one is 56 images already added to our images. So this is how to show, how to composite the images respectively one by one from the image collections. Yeah. If it's is very time consuming, we can filter again less than 20%, I think, more cloud free, or 10%. 100%, sorry. Okay, run. Oh, just 13 images. I think that is not so much time consuming. It will show the 13 images. Yeah. As you can see, the images already load as an one layer respectively. But always this one. So that's how to display, how to composite images. And the next session, how to mosaic. How to mosaic using mosaic function. So for this one, we will have an images to mosaic. And don't forget to end it with semicolon here. Yeah, because this one I divided with 10,000 to make it surface reflectance value. This is the surface reflectance value images. So I divided by 10,000 here. So I want to divide it to divide 10,000. 10,000. 1, 2, 3, and 4. Okay. Yeah. And add a layer again to show the mosaic image. Okay. Mosaic. Okay. Add layer mosaic. We give the parameter, visual parameter. Is it fish? Yes, it's fish. And give the name mosaic. I don't want to show the images anymore. Just show the mosaic images. I use the stars, slash star, and end it with slash star. And it will just show the mosaic images. Just one layer. Yeah, this one we already cut the mosaic images. Why this images jump here? Yeah, this is the mosaic image. It's not perfectly, but this is the how we do the mosaic images in Google Earth Engines. Okay, we can save composite and mosaic images. Okay. Should we take a break or we continue until it finish? Should we take a break for a while?
We finish.
We just finish it. Oh, maybe I will show you the tutorial. I will show you how to filter the images. I think yeah, I love to share it. Okay, how to filter the image? How to filter the images? I will show you how some tips. Load the images from the data catalog. Landsat, we call it Landsat. Maybe Landsat surface reflectance, tier 1. No, tier 1. Yeah, this one. You just click this one, import. Yeah, the image collection here. This one is the Landsat images from the data catalog. Landsat. We give it the name Landsat. The first step is load the image collection, and then make a polygon wherever you want. Maybe I will show. There is my Tainan. Yeah, I will show. Let's make a small polygon here. Make a polygon. Use geometry. So how to filter the image? File my image equal to Landsat, because we want to call all the Landsat images. Filter bounds. Filter bounds. This is the image boundary using geometry. This is the filter images. The first step, we want to call the images bordered by this polygon. You can set the date. Set the date. Maybe for start 2019 years, month, and date. The day. For n. The same 2009 6. Maybe I want to show you 12 to 31st December. So add the filter again. Filter date start and finish, start and end. And oh, maybe we can show the images first. Print my image. How many images we have? 0. Oh, why is it 0? Maybe we can, no images there. I think we use the slide instead. This is the filter image. Okay. Yeah, we call it again. Let's try these images. We call the Landsat image data. We delete it, just delete it. Landsat image collections. Okay, let's try. We have images here, 16 images. Using sort to sort your data. Maybe I want to sort based on the time acquisition images. Sort sensing time. Sensing time. Why use a sensing time? Because through their properties, there is, yeah, wait. Just select. Where is the sensing time? Yeah, this one. We will sort through this attribute using sensing time. Two. Okay. And run. Yeah, the images will be short as you wish. The sensing time from the January to December. And then short again, maybe short based on the cloud cover. Cloud cover percentage. 2. Again. Yeah, your data will be short. The first based on the sensing time, and the second will be short as the cloud coverage. The best one will be short in the first images, and then maybe filter meta data. We want to get the free cloud images. Cloud cover, comma, less than 20%. Run again. How many images we have? Just 5. Yeah, you can try. So this is the how to filter the images. Yeah. How to get the first images? How to get the first image? Because we have 5, we want to select one of them. We want to get the first images. So first. Let me copy the image ID because as proof. Landsat 2019 17 October. For my image, we want to get the first images. Okay. First. Yeah, you will get the first images. The first images 2019, 17 October. 2019, the 17 October. So this is how to get the first images. First page. How to get a specific image from image collection. Yeah, how to get the specific image from image collections? Maybe we want to get, this is the image pane. We want to get the image number 4 here. Let's copy this ID first. 29 July. The first thing you have to do is to make the image collections here as a list. So for my list, is okay for list image equal to my image convert to list. My image dot size. Yeah, this one will convert your image collection as a list. Run. Okay, there is no error here. If you print my list, print the list, you will get the list of images, only 5 images, and print list get number. We want to get the number 4 here. 29 July. We write here number 3. Yeah. 29 July. So that's how to filter the image. We save it. Okay, we save it again. Number 3, filtering the images. Okay, so that's how to filter the image in advance, not only through the bounds, filter the date, sort the data, the cloud cover images. Yeah, we can select the images we want to select. We want to do the analyze for more specific, the first images, or the more specific in months, maybe in July, in August, we can use this code. I already copied to you. Oh. Okay, I forgot. Here. So, what is the agenda after filtering the image? Let's do the same. Oh, limit the total images. Okay, I will limit. Okay. Okay, change the data to 2020 maybe to make it bigger. Print my image. Okay, only make it bigger. 24 elements here. We have 24 images. We want to do the limit. limit the number of image collection. I forget. Okay, file limit my image dot. Okay, we can do the limit maybe 10 and to the print limit. Keep the name. Okay, to the run. Yeah, the difference is the first one we have 24 images, and after we do the limitations, to the limits the number of image collections, the number changed to the 10 images. They select the top 10 of your from your list. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They will get 10 from your list. So that's save again. And then what is the NDVI calculations through GEE? Okay, maybe. Okay, we can clear the script again. Okay, clear. Bye-bye. Where is the okay. Okay, we just copy everything from the PPT to make it faster. The first thing, we make a polygon. This polygon, this point located in Ethiopia, Africa. I just select the location randomly. Select the set the date. Okay, I will copy paste to you. Okay, if there is a warning notifications, please retype the quotation mark. Yeah, everything is fine now. And filter the data set. Filter the data set. Ethiopia. Okay, Ethiopia. Filter the data set. We filter through this point and filter the date from March to July in 2020, because we use the Sentinel images. It's different than the Landsat. We use the cloudy pixel percentages. If Landsat, they use cloud cover. If Landsat, they use cloud cover. If Landsat, they use a Sentinel. We use cloudy pixel. Yeah, this is the different features from the Landsat and the Sentinel images on GEE. If Landsat, they use cloud cover to filter the cloud cover images and cloudy pixel percentage. Okay, and then to the NDVI calculation, because we use the near and red bands. Yeah, the first we select the near the red band. Near is band 8 and the red band is band 4. Okay, select NDVI calculations here. Near and red, we already select the bands. And yeah, they have 3 ways to calculate this function. The first one, we use the NDVI using the subtract, red, divide, and using this one, using the basic common mathematics symbol, add, subtract, and divide. And then the second way, we use the expression functions, when 8, when 4, as the same as with these functions. Okay. Okay, I will copy to all of you because we run out of time. This is the second NDVI. We use the expression functions. We pen 8 subtract with pen 4 and divide it with pen 8, add it with pen 4. And the third way is use the normalized function. Yeah, this way is how to calculate the NDVI from 3 functions. Yeah, set the color because we want to give the color of our NDVI result. Yeah, this is NDVI palette. Again, if the code doesn't work properly, just we type the quotation mark. Okay, the warning is gone. We already set the color palette and add a layer. It's the interesting part. I forget to copy to all of. Yeah, give the set color palette to your NDVI. Okay, where? Yeah, okay, everything is fine. I can copy to all of you. Yeah, we add a layer NDVI 1, NDVI 2, NDVI 3 with the minimum is 0, maximum is 1. The color through our palette, the NDVI palette, and we will give the name NDVI 1, NDVI 2, NDVI 3, and let's fly to Ethiopia. Okay, this is the NDVI result from the NDVI 1, NDVI 2, and NDVI 3. So this is the NDVI 1, NDVI 2. Yeah, everything still show the same result because that's how to calculate the, yeah, how to apply the pen math functions to GEE. Okay, then we finish with NDVI calculations. NDVI calculation. Okay, I think because there is because our time, the limitation our time, I can provide to all of you this code, this tutorial, because we still have NDVI calculations. But what is this? I forgot. How to make a graph, how to make a scatter plot, how to make time series NDVI graph using a previous location, for example. And yes, scatter plot, I still histogram, how to make histogram, how to import and export data, how to export data to your asset. Yeah, this one is different because it's associated with Google. The export the image will have 2 ways. The first one is to asset, and the second way is to our Google Drive. So you can try after we upload this slide. And also I provide the digital image processing by using GEE. we yeah, we still have more code for the image pre-processing, image projection, image registrations, rescaling, and cloud shadow masking, gray level thresholding, level slicing, edge detections, and pen sharpening. Yeah, how to cloud masking. Yeah, we still have more codes for all of you. I think that's all for me. If do you have a questions, you can please share this tutorial. Oh yeah, of course. I will upload it to yeah, and I will share everything to you guys. I think that's all for me. If there's a questions, you can write your questions on your in this comment section, and I will happy if I can answer it.
Okay, thanks Abby's presentation. And if there's no further question, then we will give you a small quiz. OK，那孟哲在吗？
在我分享，哎，有人有分享。
好。
Okay, everyone, please write down your answer for these two questions. And if you have any question, you can just write down in chat room to ask Dr. Lin and Dr. Girl. Ready?
Grab
Yeah.